So let's go ahead and get started with this bell ringer. Starting with number 1. So let's just quickly review how this works with addition. So if I'm just adding these two, what should I be doing first?
Combine like terms.
Good. We're just going to combine like terms. So let's take a look. Where do we see like terms?
5p and 2p.
5p squared and 2p squared. Good. That's it. There are no more like terms. Everything else is not like terms. So we just combine these two together. 2 and 5 make 7p squared. And then I'm just going to bring everything else down. So I have a -3 and I have a -3p cubed. Now, am I done?
But Miss, I have a question.
Sure, Marian.
Why isn't it, or why are we not combining it with 3p? But it's because it's -3, right?
So the reason we're not combining it with anything else is because think about what the definition of like terms. What are like terms? Or what do they have to have the same? And this goes for anybody.
The variable and the coefficient.
Same variable.
And same exponents.
Same exponent. So it's all about the exponent. So if you look, these two are matching because they both have a 2, but the others don't. So that's why those are the only ones that are like terms. Does that make sense?
Oh, yes.
Okay, cool. And that's something that like it can be really confusing at first, but the more practice we do, the more like intuitive it's going to become. Okay, so I have 7p squared minus 3 minus 3p cubed. Is that my final answer, or should I do something else to it?
Put it in standard form.
Good, Melanie. And so what does standard form mean? What am I doing when I put it into standard form?
Highest exponent to lowest exponent.
Highest exponent to lowest exponent. So this cubed goes first, then the 2, and then that 3 at the end will go last. So I'm just rearranging it, and let's be very careful because this whole thing is -3p cubed. So I have to have -3p cubed, then the 7p squared, and then -3 goes at the end. So after you finish combining like terms, you always want to rearrange it so that it's in standard form. Do I have any questions so far? Okay. Now, a couple of just quick review things. What is the leading coefficient?
-3.
-3. And in my original problem, let's just go back to the top for a second. What type of polynomial is this?
Trinomial.
A binomial. So I had a binomial plus another binomial. And what was my answer? What type of polynomial?
Wait, what?
Miss, isn't it polynomial? Because if it's 4 and up, it has to be a polynomial.
So if it's 4 and up, it is polynomial, but how many terms do I have? 1, 2, 3. So what does that make it?
Trinomial.
Trinomial. So it's a trinomial with a leading coefficient of -3. Any questions on that kind of vocabulary stuff? Cool. Let's do number 2. Oh, I don't need to erase that. Okay. Number 2, same idea. First, we look for like terms. So where are my like terms? Somebody name a pair of like terms.
-4k cubed, or
To the power of 4.
to the power of 4, and -3k to the power of 4.
Good. Those are 2 like terms. Somebody else, give me another pair of like terms.
14 and -8.
-3k2 and -14k2.
Good. I heard both of you at the same time, and you're both correct. So we have my k to the power of 2's, and then the 14 and the -8. Here's a quick question. Does anyone remember what these numbers are called when they don't have a variable? We didn't really go over it, but I just am curious.
Coefficients.
Close. It's not coefficients, but it does start with a C.
Constants.
Constant. Good. That's a constant. So anything that doesn't have a variable with it is just called a constant. Okay. Now let's go ahead and put them all together. So -4 and -3 gives me?
-7.
Good. -7, k to the power 4. 14 minus 8. 14 minus 8
6.
is 6. And then 3 minus 14,
-11.
-11. All right, and then again, as my last step, I just have to rearrange it so that it's in standard form. So what needs to switch?
The order they're in.
The order that they're in. So what should go first?
The -11k squared cubed has to
Squared.
go in squared has to go in the second.
Right, so basically I'm just gonna switch both of these, okay? Because the first thing is the exponent of 4, then the exponent of 2, and then my constant goes last. What's the leading coefficient?
-7.
-7.
-7. What type of polynomial is this?
Trinomial.
Trinomial. All right. Questions on these two problems? Awesome. So with addition, it's really just a matter of practicing how to combine like terms. So we're just going to do a couple more. Now what I want to do is, since we did already with the bell ringer, let's see. I have a few examples. Let's do this one. I want you guys to try these on your own, and hopefully it helped to review it a little bit just now. So go ahead and try both of them. I'm going to put 4 minutes on the clock, on the timer. And you can send me your answers in the chat. And then after this, we'll move on to subtraction. Okay, about a minute and a half left. Okay, just about 15 seconds remaining, so finish up and send me in the chat. All right. Sorry, just trying to respond. Thank you guys, so many responses. That's always good. If you hear me typing, that means I'm hearing back from a lot of people. So that's really good to know. Okay, so let me see. Okay, so in the first one, what are my like, somebody give me a pair of like terms.
Both 13n squared.
Good, so I have 13n to the power of 2, and then I have negative 13n to the power of 2. What else?
2n to the power of negative 2n to the power of 4 and negative 6n to the power of 4.
Mm-hmm. And then these as well. Okay. So a couple people were maybe a little bit confused by this, so I definitely want to just make sure we understand. If you have 13 oranges and then you subtract 13 away, how many are you left with?
0.
0. And that's what's going on here. I have a positive 13, but then I have a negative 13. So that's like if I gave you $13 and then I took away $13. You're left with nothing. So this is actually 0. So that those two, when you combine them, you get 0. But what about everything else? What do I get here? 11 and then
8.
negative 3. Good. 8. 8n, so that's 11 minus 3 gives me 8. And then what about here? Negative 2 and negative 6. What does that make?
Negative 8 squared.
Negative 8n to the power of
4.
4 to the power of 4. So remember, when you combine like terms, that exponent does not change at all. The exponent stays exactly the same. The only thing that's changing is the number in front because you're combining them. Okay, so I'm combining 2 and 8, or 2 and 6 make 8. Negative 2 and negative 6 make negative 8. Now, if I want to rearrange this, is it in the right order or do I have to flip them over?
You have to flip it.
Flip them.
Flip them. Now, which of these numbers, which of these terms is negative?
The negative 8 and 4.
Good. This is a package deal. It goes together. So when you flip them around, you get negative 8n to the power 4 plus 8n. Why do I put how do I know that this is positive?
There's an invisible plus behind the 8.
Right, there's nothing in the front, so because of that, I know it's automatically positive. Automatically positive. So If there's a minus sign, it's negative. If there's a plus sign, it's positive. And that's my final answer. What type of polynomial is this?
Binomial.
Binomial.
It's a binomial with a leading coefficient of?
-8.
Negative 8.
Good. -8. How do we feel about number 1? Do I have any questions? Any remaining questions? Okay. Similar idea with number 2. Let's have 3 volunteers give me 3 pairs. Well, actually, there might not be 3 pairs. Let me have 1 pair of like terms.
-7 to the power of 5 and 5x to the power of 5.
Good. So there's 1 pair of like terms. What's another? Is there another pair of like terms?
Negative 2x and 7x.
-2x and 7x. Anything else?
No.
No, ma'am.
No, ma'am, that's it. That is it. So let's go ahead and combine. I have these two. -7 and +5. What does that get me?
Negative 2x to the power of 5.
-2. Good. -2 x to the power of 5. Now I have this 14. I'm just going to bring it down. Then I can combine these two. What's -2 plus 7? Good, Daniela, 5x. And then this 10 comes right down as well. Now I can rearrange everything and put it in the correct order. So which of these is going to go first?
Negative 2x to the power of 5.
Good. That stays right where it is, right? Because that's the biggest exponent. What should go next?
10x to the power of 4.
Is that a positive 10x or a negative 10x?
Positive.
Positive 10x. It has a plus sign in front of it. So it's plus 10x to the power of 4. What comes after that?
Plus 5x.
Plus 5x. Because again, there's a plus sign in front of it. You always want to look in front. And then finally, my 14. Okay. Can I give this a name, or is it just going to be a polynomial?
And polynomial.
Polynomials is 4.
Good. Leading coefficient?
-2.
-2. What's this number here called? The 14.
A constant.
Constant.
Good. We're getting it. Good job. Okay, now I had a question about the first one we did just now. And by the way, yes. So for those who might have been absent yesterday, let's just real quick, everybody, if you know the answer, shout it out. If a polynomial only has 1 term, what is it called?
Binomial.
Close. Not monomial, but it does start with a
Monomial.
monomial. So think of like mono, what's I don't know. Monosyllabic means it has 1 syllable. What's another word that starts with mono? I don't even know. I feel like that's not that common, but mono is 1, so monomial is 1. How about 2 terms?
Binomial.
Binomial, so like bicycle, bi. 3 terms?
Trinomial.
Trinomial, tricycle. And then anything after that is just a polynomial. We don't bother with it after that. Okay, now I had a question about number 1. Somebody asked me, let me go back, to just clarify the positives and the negatives. So let me go back over here and just go from this step over here. So when I combined -11 No, positive 11 and negative 3. 11 minus 3 gave me positive 8. So another way to write this would be to put a positive in the front because it's positive 8. Then negative 2 and negative 6 gave me negative 8n to the power of 4. So when I rearrange this, when I flip them around, because we know that the exponent of 4 has to go in the front, we take the sign with us. So that 8n to the power of 4 is really a negative 8n to the power of 4. So when I switch them around, I end up with negative 8n to the power of 4 plus 8n. So I'm just going to highlight that to make it really, really obvious. The sign comes with it. Okay, so I hope that helps to clarify a little bit. Does anyone have any other questions? Okay, so I think we're ready for subtraction. I know some of you guys who are in my period 1, we did it already, but it's going to be another different question, so you'll get to review it a little bit as well. Okay, so here's 2 problems. We are subtracting this time. And luckily, with subtraction, it's almost the same thing. There's just one added extra step. Can anybody from my period 1 who already learned this tell us what that is?
The minus sign applies to everything to the whole equation to the right.
Right. So the minus sign that's here, what we have to do is we have to distribute the negative. So the minus sign gets applied to everything that comes next. Now, what does that really mean? Think about it. When you apply a negative number, what is it going to do to each of the signs on the inside of the parentheses? Right, they would flip the sign. So anything that is negative is now going to turn into a positive. Because remember, what happens when you have 2 negatives put together? 2 negatives put together are going to turn into a plus sign. So what happens is, this stays exactly the same. But the second polynomial, we're going to flip each of the signs. So negative 6 becomes positive 6. Negative 3 becomes positive 3. And negative 8 becomes positive 8. And again, the reason we do this is because when you have a minus sign, that minus has to be applied to everything inside of the parentheses. So when we distribute that negative, we flip the signs. And from there, it's the same as addition. From there, we can treat it exactly the same way as addition. So we're just going to do the same steps. We're going to find all of our like terms, combine them, and then write it in standard form. So any questions at this point? Awesome. Okay. So combining like terms. Somebody name me one pair of like terms.
6n to the power of 5 and negative 6n to the power of 5 plus 8 positive 8n to the power of 5.
Beautiful. There's one pair. Any other pairs?
Negative 8n squared and 6n squared.
Careful, it's not squared, it's just to the power of 4. Because what's squared?
2.
2 is squared. 4 doesn't really have a word. You just say to the power of 4.
Oh, okay,
cool.
thank you.
No problem. All right, so now we're ready to combine. Now, when you combine like terms, I'm going to give you a little secret. Some of you might already do this, but what you can do is you can do it in the order of standard form right away. So if I'm doing standard form, which of these should I combine first?
The 8 The 1 to the power of 5, both of the ones that are to the power of 5.
Good, the ones that have an exponent of 5. So I can kind of do it now. I can put them into standard form right away rather than waiting until the last step. So let's go ahead and try that. So -6 and then 8, what does that give me?
2n to the power of 5.
2n to the power of 5. Which should I write down next?
The 8, and then -8n to the power of 4, and plus 6. Yes, there we go.
All right, and what does that give me?
-2n to the power of 4.
Good. Now I have a 3 and I have a 3n. What should I write next?
3n, then 3.
3n and then 3. And there's my final simplified answer. So just as a recap, what did we do? We had to distribute the negative. So we had to flip all the signs. Then we combined like terms. And this time around, when I combined like terms, I tried to do it in the order of standard form. That way, I mean, you don't have to do it that way. I'm not saying you have to do it that way. But when you do it this way, you kind of get to skip that final step where before we kind of had to rearrange things at the end. Well, you can kind of cut to it this way. You don't really have to do that step anymore. How do we feel? Any questions on number 1? Okay, let's try number 2. Same thing. I have a minus, so I'm distributing. My first polynomial stays exactly the same. We're not changing it at all. But what do I get for my second polynomial?
-3n to power squared,
Mhm.
-11n to the power of 4, and then +7.
+7. Good. So anything that is negative turns positive. Anything that is positive turns negative. And now at this step, I want everyone to try it on their own, combine like terms, and let's see if we can get the right answer. All right, take about 30 more seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Cool. So I'm seeing some good answers in the chat. Let's start with combining like terms. So what do I have? Which of these are like terms?
10n to the power of 2
Mhm.
and 3 negative 3n to the power of 2.
Beautiful. All right, and then I see one more. What is it?
Negative 3n to the power of 4 and negative 11n to the power of 4.
Awesome. All right, let's get to it. So which of these should I combine first?
The 11n and the 3n both negative.
Good. We're going to do those first because they have the highest exponent. So we always just want to start with the ones. That way we can do it in standard form. So what is negative 3 and negative 11 combined? What do I get?
Negative 14.
Negative 14. I'm not changing the exponent. I'm not adding anything. I'm not multiplying anything. I'm just combining the negative 3 and the negative 11. What should I combine next?
The 10n and the negative 3.
Good. And what's 10 minus 3?
7.
Positive 7. All right, who goes next? Good, Daniela, 8n. And what's this number called again? What goes last?
Constant.
The constant. Good. Good, good, good. All right. So here we got two polynomials. These are for both number 1 and number 2. They're just polynomials because they have more than 3 terms. What was the leading coefficient for number 1?
2.
It's 2. What was the constant?
3.
3. What's the leading coefficient here?
Negative 14.
14.
What's the constant?
7.
7. How do we feel? Questions on subtraction?
Easy.
It's almost exactly as addition. You just have to remember that first important step of flipping the signs. Okay, we're going to do one more together, and then from here on out, we're going to do kind of independent practice problems. Check this one out. It's a little bit different. So this one is telling you to subtract the first trinomial from the second trinomial. So when I write it out, now I'm going to write it down, but which one should I write down first? If I'm doing blank minus blank, which one goes first?
You should do the first one. Or
So
you should do the second one because it says subtract that from.
yeah, so we want to be very careful because, for example, let's just say that I wrote this. If I'm telling you to subtract 3 from 8, what are you actually doing?
You're
Subtracting 8
subtracting
from
8 from 3.
No, I'm subtracting 3 from 8, but how do I write it?
8 minus 3.
8 minus 3, because you're taking away the 3 from the 8. So that means you got to start with 8 and take away 3 to give me 5. So it's the same exact situation over here. If it's telling me, okay, subtract this green one from this pink one, I start with the pink one. And I'm subtracting, I'm taking away this one. So be very careful because it's a very common mistake to do that one backwards. And on your homework assignment, which is already up, I know a couple people already got started on it, but on your homework assignment, they do this a few times. So we want to be very careful and make sure that you're writing it in the correct order. So from here, try it on your own, see what you get. Take about 30 more seconds. All right, and 5, 4, 3, 2, and 1. All right, let's go through it together. What do I do first?
Distribute the negative.
Distribute the negative. Good. When I distribute the negative, what do I do to each sign?
You add a negative in front of it.
In other words, we flip.
Flip it.
All right. So first one stays the same. Then I have negative 4p squared plus 9p minus 11. And from here, we're just going to combine like terms, which means, I say that like it's easy, but we got to be very careful when you combine like terms because it's super easy to make a silly mistake. Super, super easy. So that's why I like to take it very organized, very slow. I like to color code things. So if you have pens or colored pencils and you like to color code, that could be helpful as well. Okay, give me 2 pairs of like terms.
P squared
Mhm.
and negative p squared. Negative 4p squared.
Negative 4p squared. Good. Now, the p squared, it just looks like it just has a p squared, but what's in front of it technically?
1.
Good. There's a 1 in front. Okay, what else? Give me 2 other like terms.
Negative 5p and positive 9.
Good. And then finally,
11. 4 and negative 11.
4 and negative 11. Okay, beautiful. Let's go ahead and combine them. 1p minus 4p. What does that give me?
Negative 3.
Negative 3p squared. Then negative 5p plus 9p. What does that give me?
4p.
4p, good. And then finally, 4 minus 11.
Negative 7.
Negative 7. So there we go. There you have it. Trinomial with a leading coefficient of negative 3 and a constant of negative 7. How do we feel about this one? Any questions? I feel like we're getting the hang of it. The more practice, the better. But take a look if you made any mistakes or if you weren't really sure how to go about it. Make sure that you understand. Ask me anything, any last questions you might have. Okay. All right, so like I said, from here on out, we're going to do some slightly more challenging practice problems. But I do want to start with just one more, just get one last shot to just do kind of more simple ones. And then from here, we'll kind of add 1 or 2 things each time. So go ahead and take 5 minutes. I'll set a timer. 5 minutes to do these 2 problems on your own. Send me your answers when you have them, and then we'll move on. About 2 minutes remaining. And again, send me your answers in the chat if you have them. All right, you guys, that is time. So let's check this one out. I saw a mixture of correct responses and incorrect responses. So anyone who got it wrong, by the way, it all comes down to little tiny silly mistakes. So we have to be very careful and iron those out now and just make sure we learn from those mistakes so that when it comes time for like a quiz or a test, at that point you feel good about it. So it's okay to make mistakes now. In fact, that's totally fine. Just make sure that you learn from them. So number one, which of those polynomials am I writing first when I write it out?
The positive. Oh, the second one.
The second one, yeah. So we write this one first. So it goes 8b cubed minus 6 plus 3b to the power 4 minus b to the power 4 minus 7b minus 3. So again, since you're taking that one away, you have to kind of write it backwards. Well, now I go ahead and I go to step 1. I'm going to distribute my negative. My first polynomial stays the same. But now I have negative b to the power of 4. I have positive 7b, and I have positive 3. Any questions on that first step? Any questions on just that first step? Make sure you got that one right. Okay, now I go ahead and I find my like terms. Well, what like terms do I have here? Oh, I forgot to write the 4. There we go. What like terms do I have here?
AB3. Oh no, 3B4
Mm-hmm.
and the negative B4.
Mm-hmm. And then I also have my 7 and my 8b to the power of 3, and then my constants, negative 6 and positive 3. Okay, so by the way, why did I write, somebody asked me, why did I write it in that order? That's because I'm taking, one more time, let me make sure it's very, very clear. I'm taking this polynomial away from that polynomial. So I start with the second one and I take away the first one. That's why I had to flip them around. Now I can combine like terms. So I start with my b to the power of 4. 3 minus 1, what's 3 minus 1? We got 2b to the power of 4. Then my 3's, 7 plus 8. 15, b to the power of 3. And then finally, negative 6 plus 3, what does that give me?
3.
Positive 3?
Oh, negative 3.
Negative 3. There you go. 2b to the power of 4, 15b to the power of 3, and the constant is negative 3. So there were a couple people who made small, tiny mistakes, like maybe you forgot to flip the signs. If you forget to flip the signs, that's gonna make a big problem, right? So little things go a long way. Do I have any questions on number 1? Can somebody remind me why I'm writing it in this order?
So you won't have to like do the last step to like put them in order.
Right. So when I have the final answer, you always want to have it in standard form, which means that the highest exponent goes first, then it goes down from there. So the reason it's in this order is because the exponent of 4 has to go first. Okay, Marco, you have a question? Go ahead. When we subtract, do we have to do what we did in this question or not? So good, I see what you mean. So these two problems are given to you differently. So the first one is telling you to subtract this from that. So we have to flip it. But in example number 2, it already wrote the subtraction problem for you. So in number 2, am I going to switch them around or write them any differently? No, this one's already given. It's just saying find the difference. So when it's already written out as a subtraction problem, you just go right ahead and you distribute the negative first. So that's why I gave you one of each. In the first example, if it tells you, like using words, if it says, oh, subtract this from that, then you got to rewrite it. But in the second example, it already gives you the subtraction problem, so you do not need to rewrite it. So good question. All right, so we flip the sign, and here we go. First one stays the same, 13a squared minus 6a to the power of 5 minus 2a. But now on my second one, I have positive 10a squared, positive 11a to the power of 5, and negative 9a. Okay, any questions so far on this one? Cool. Now, like terms, I have negative 6a to the power of 5, positive 11a to the power of 5. I have 13a squared, I have 10a squared, and then I have negative 2a and negative 9a. So when I put them together, which one should I write first? Which color should I put together first?
The pink one?
The pink one, yeah, because it has the highest exponent. So we're going to write it in order. So first one is the highest exponent. So what's negative 6 plus 11?
Positive 5a to the power of 5.
Good. Positive 5a to the power of 5. Then I keep going in order of exponents. So the next, what color would go next?
Uh, 13a squared and positive 10a squared.
Good, the blue one. So it's 13 plus 10. Good, Daniela's got us 23a squared. And then finally, my green ones. -2 and -9 give me -11. -11a. There's our answer. So take one last look at these two examples, because this is the last two that are very straightforward. Like I said, the next few that we're going to do start to get a little bit more challenging. So as long as we understand the basics, the challenging ones will be not too bad. So go ahead and take a look. I'll give you guys another minute or so to just make sure we understand every part. Oops, sorry. Okay. Any final questions? Any final questions on subtraction? Okay. All right. Let's do this one. So this one's only just adding one little different thing. What's different about this one? Look at it carefully. What's different? Good. I see Daniela says there's a 2 on the outside. There's a 2 out here on the outside. And we know that whenever there's a number on the outside of the parentheses, we're going to have to distribute. So that's not too bad. That's not too bad at all. When you distribute something, what operation are you using?
Distributive property.
Multiplication.
Multiplication, distributive property. So here, 2 times 3, I get 6g. 2 times -4, I get -8. And from there, it's the same thing as before. We're just doing subtraction. So go ahead and try this one on your own. And when you're done, put your answer into our poll. Awesome. I already see 10 people have put their answer in, so I'm just missing about 9 of you guys. Take another 30 seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Cool, guys. So I'm not going to share the responses yet because I want to go through it first, and then you'll see what the answers looked like. So remember, at this stage, I'm subtracting. What do I have to do first?
Distribute the negative and the 2.
Good. Distribute the negative as well. Don't forget that part. And when you distribute the negative, it goes to everything on the inside of the parentheses. So when I rewrite this, I have 6g minus 8 minus 8g minus 3. So combining like terms, this is where we got to be very careful with our addition and our subtraction. 6 minus 8, well, okay, what does that give me?
-2.
Negative 2. Good. And then negative 8 and negative 3. What does that give me?
Negative 11.
Negative 11. So it makes it D. D is our answer choice. Now, I'm going to share the responses. Let me show you. Look how close it was between B and D. A lot of people chose B by accident. So what did those people do incorrectly? And it's okay
They
if you got
didn't
it
make
wrong.
it a negative.
They were supposed to flip the signs. Half the people didn't.
Right. So half the people made that a positive 3 instead of a negative 3. So this is where I'm saying, like, little tiny mistakes like that, they go a really long way. So we have to be super careful, super organized, and just make sure that when you're doing all of these like negatives and positives, you're thinking about it really deeply. Don't do it like in your head really fast and then think it's right. Take a moment and really think through the whole problem.
One way you could have done it is just distribute the negative and then add the constants together, and because since they both have the same, since they all have -2, if you just look at the constant, it would have been easy to find it was negative 11.
Yeah, so this part was the same in all of the answer choices. So that part was kind of already given to you. So it's really about making sure you have the right constant, negative 11. Any questions on this one? Cool. Here's a very similar one. Try this one on your own. Same idea, try it on your own and put your answer in the poll.
We can't, there's no answer choices.
Oh,
don't
duh,
see
I'm
any.
sorry. I'm sorry, I just realized that too. So you just have to do it on your own. There's no answer choices. So try it on your own. I'm sorry. Take about 2 minutes. See now that we're kind of getting the hang of it, see how fast you can get it done. See if you can get it done in those 2 minutes. Okay, 45 seconds remaining. That's okay. I'm not going to give away whether he's right or wrong. All right, that's time. Let's check it out. I haven't replied to anybody yet, so I see all your answers, but I have not replied. Let's take a look. First thing, what do I do? Distribute the 3, good. Distribute that 3, here we go. What does that give me?
9k squared, 9k squared,
9k squared,
negative 12k,
negative 12k,
and positive 16. I mean 18.
positive 18. Good. Then, here's the rest of it.
You distribute the negative.
Then I'm going to distribute the negative. Good. And I'm seeing these answers in the chat. Sorry, I haven't had time to reply to everybody, but I'm seeing lots of correct answers in the chat. Keep sending them. When I distribute my negative, I'm going to flip the signs. So I have 9k squared minus 12k plus 18. That doesn't change. But what do I get here?
Negative 8k squared, negative 1k squared, no, negative 1k,
Just k.
and then negative 3.
Negative 3. Beautiful. Okay, we're almost there. Now we go ahead and we combine all of our like terms. So let me highlight them. 9k squared and negative 8k squared, negative 12k and negative 1k. Remember, there's a 1 there. And then 18 and negative 3. So if you had something different at this step, I want you to take 30 seconds, fix your mistakes, and go from here and get a final answer. Oh, the afternoon announcements are on. Yes, Alyssa, can you unmute yourself? Oh, it's really loud. It's actually a little bit hard to hear, so I'm just going to mute it. But let's just finish this problem and then we'll be almost done. So combining like terms, what do I get for these k squares? Nine k squared minus 8k squared. Good. 9 minus 8 just gives me 1. So I just have 1k squared. Then negative 12 and negative 1. What does that give me? Good, negative 13. Okay. And then finally 18 minus 3. 18 minus 3. 15. So there it is. K squared minus 13k plus 15. Questions on this one? 5 minutes left in class. We're going to do one more problem. So any final questions before we do our last problem of the day? All right. Let me find the one that I want to do. Here. Okay, this looks confusing, but it's not. So I want everybody to take a moment and read along with me. It says, if p of x is x squared plus 2x minus 5, and q of x is x minus 3, what is p of x minus q of x? So they're basically saying, okay, here's p of x, here is q of x. I want you to subtract these two. So I'm just going to go ahead and I have x squared plus 2x minus 5 minus x minus 3. So take these last 5 minutes, put your answer in the poll. Oops. Put your answer in the poll, and we'll go over it real quick, and then we'll be done for today. All right, since I know the bell's going to ring pretty soon, take about 10 more seconds to get your answer in. We'll go over it real quick and then we'll be done. So 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Here we go. Results are in. C was the winning answer. Let's check to see if that's correct. So first things first, I distribute my negative. I'm going to rewrite it. I have x squared plus 2x minus 5 minus x plus 3. Then I have like terms right here. And I have like terms right here. The x squared doesn't have any like terms. So when I write it down, I just copy it right down. 2 minus 1 gives me 1. So 1x. And negative 5 plus 3 is negative 2. So answer choice C was correct. Good job if that's the one you chose. If you didn't choose it, make sure you understand. So ask me any questions if you have them. Make sure that you review what we worked on today, because a lot of you guys are getting it really well, and that's good, but we want to make sure that we're practicing it. Even if you understand it 100%, practice is what makes perfect. You'll make less and less mistakes the more and more you practice. There is homework. It's been up since yesterday, and now you've officially, everyone has learned everything that you need to do the homework. So tonight would be a good night to get it done if you haven't done it yet. And if you have any questions about the homework, we can talk about it tomorrow during class. And that is everything for today. So have a great afternoon, everybody. I'll see you tomorrow.
Bye, Miss Lover.
Bye, Miss.
Bye. Bye, Cassie.